All right, let's look at more of L'Hopital's rule examples. All right, so let's look at this first example. All right, so if so, first thing we should do whenever you're evaluating a limit, you just have to plug in and see what happens. All right, so as x approaches infinity, the numerator, natural log of infinity, is still going to be infinity. And the infinity cube is going to be infinity. So we get infinity over infinity. This is the second indeterminate form. All right. So what we can do is we apply L'Hopital's rule. So by apply L'Hopital's rule here, so we have a limit as x approaches infinity. Right, so derivative of x cubed is 3x squared, and the derivative of natural log of x is 1 over x. Right, and I don't like having a fraction inside a fraction, so I'm going to go ahead and multiply top and bottom by x. Right, that way I can cancel x here and x there. And what you get is just this. Limit as x approaches infinity, right? Then you have just 3x cubed, right? But 3x cubed as x goes to infinity is going to be infinity times 3 is still infinity. So answer is infinity. Right? So it blows up to positive infinity. So this is the second kind of indeterminate form. Whenever you have infinity over infinity, you can apply L'Hopital's rule. All right, and I'd like to go over another example. All right, this example is an example where L'Hopital's rule can be applied multiple times. All right, so let's do that. All right, if you look at the bottom, you have 0 cubed, so it approaches 0. All right. And e to the 0 is 1, minus e to the 0 is 1, so 1 minus 0. So again, the numerator approaches 0. So what we can do is apply L'Hopital's rule. Alright, so we have a limit as x approaches 0. Right, derivative of e to the x, e to the x, because this is one of our favorite function. And derivative of e to the negative x is negative e to the negative x. So there is a negative sign already here, so double negative. So plus e to the negative x. Then derivative of negative 2x is negative 2. And derivative of x cubed is 3x squared. Right? Then plug in. And you see that as x approaches 0, denominator still goes to 0. Right? Numerator, e to the 0 is 1 plus e to the 0 is 1, so 1 plus 1 minus 2. So the numerator again goes to 0. So there's no point of stop applying the L'Hopital's rule. We just keep on applying L'Hopital's rule as long as we have infinity over infinity or 0 over 0. So we have a limit as x approaches 0. Alright, derivative of e to the x is e to the x. Derivative of e to the negative x is negative e to the negative x. Derivative of negative 2 is 0. Derivative of 3x squared would be 6x. Right? Then you send x goes to 0. Right? 6 times 0, denominator still goes to 0. E to the 0 is 1, minus e to the 0 is 1. So 1 minus 1, this guy still goes to 0. Right? So this is the third time to apply L'Hopital's rule. Hopefully this is the last one. So limit as x approaches 0. Right, derivative of the denominator 6x is 6. Derivative of e to the x is still e to the x. Right, derivative of e to the negative x is negative, so it's going to be plus e to the negative x. Alright, then we plug in. Alright, so the denominator is 6. Alright, so we're done applying L'Hopital's rule because you don't have 0 there or infinity. And the numerator is e to the 0 plus e to the 0, which is 1 plus 1. So this approaches 2. Alright, so therefore you have 2 over 6, which is 1/3. right? So this is the limit of the value of this limit right here. All right. So as long as you have indeterminate form, which is 0 over 0 or infinity over infinity, you can keep on applying L'Hopital's rule until you get to the answer. All right. That's it. I hope that this was clear.